What you got, Hayden?
I'm just going to take a guess.
Okay.
Polarized?
No, that's all right.
Okay.
Ryan? Two types of charges.
Positive
Positive and
and negative.
negative.
You see. We don't talk about it.
That's all right. Positive and negative. Now, this is not one of the questions, but I want to see if you were able to notice it. Jack, which ones of those seem to move? When you did all the labs, when you did all the motion and that kind of stuff, which of those two seem to be the ones that move?
Negative.
The negatives are the only ones that move. So go ahead and add that. The only ones that move are the electrons. Electrons go in, electrons go out, but the electrons move, the protons stay where they are. Okay, so rubbing the balloon on the sweater moves electrons onto the balloon. Now the sweater has fewer electrons, so it's positive. The balloon has more electrons, so it's negative. And what seems to happen? Let's see, Ethan, part one. What do you got for what do opposite charges seem to do then? They're going to attract. Okay, make both the balloons negative. What happens with that one, Jared? Yeah, light charges repel. Franchise, what about that last one here for station 1? What seems to happen? Why is it attract to the wall? The wall's neutral. It has the same number of protons and electrons. Why does the balloon attract to the wall?
I said because the balloons are attached and then one of the balloons are under direct contact with a charged object.
Okay, so one's attracted to the sweater. It's going to repel the other one. But what's going on with the wall business? So let's look at this here real quick. All right, two balloons, negative charge, okay, repelled. I want you to see what happens to the wall. Notice that as I get closer to the wall, see what happens to the electrons in the wall? See how those electrons get kind of pushed out of the side? What does that make the wall right there? Positive. So why does the balloon attract to the wall even though the balloon is not charged, or sorry, even though the wall's not charged, is because it moves electrons out of the way. And this is called polarizing. All right, let's talk about the Van de Graaff. So the spark thingy, okay? So we're cranking. Sparks are jumping from one side to the other. Ashton, what do you think's happening?
The friction and the conductors generate electricity.
Yeah, so what's happening is electrons are moving from one side to the other. And they do that because as the wheel rotates, it pulls electrons off of those plates and they make an imbalance. One side is positive, one side is negative, and they jump from one side to the other. So here's my super awesome diagram.
We can't see that.
Thanks. Here's my super awesome diagram. One side becomes positively charged, one side becomes negatively charged, and it jumps from one side to the other. So that's what's happening. Okay, so conductors versus insulators. Let's see, Carson Pugh, Carson Part 1. What do you got for conductors versus insulators?
I said conductors let electricity, the electric charge flow, and insulators don't flow electric charge.
Good. So conductors allow charge to move easily. And insulators are difficult to move charge. It's not how you spell difficult, but don't worry about it. Yeah, don't worry about it. All right. Move the rods further apart. You put the tape in between. You put the paper clip in between. Carson Part 2, the return of Carson. Carson Bowers. What about, which one was the insulator? Which one was the conductor? Yep. The electricity does not want to go through the tape. It does want to go through the paper clip. And so that's why it enables it to move through easily, because the paper clip is a conductor. But the tape is an insulator. Good? Moving right along. All right, station 3. Martin in the back, tell me what polarization is.
Polarization is the act of separating into options.
Separating charge. Specifically, positive and negative. Okay? So, Solus, tell me about induction. How does induction work?
You start with a charged object near the initial object. Well, the first object is near the second object. Now the third object comes center to the second object. And it's pulled away, and the second object is charged.
Okay. So you start off with something neutral. Same number of protons and electrons. You bring a positive or a negative object over, and that switches the charge. So now these electrons that were over here come over here. So now this has a negative charge on this side and a positive charge on this side. You then bring a third object in contact. And that third object will bring in electrons or pull out electrons, depending on what it is. So this side is positive, so it will bring up electrons. When you do that, those extra electrons will go on the object. You take the original object away, and now you've got more electrons than protons, and it's negatively charged. Induction is complicated. Basically, what you do is you polarize an object, and then you either add or remove electrons from it. Specifically from a third object. All right, so John Travolta, we have his finger by the doorknob, rub his foot on the carpet. What happens for that Roman? What happens to him?
Well, the negative charge gets, and when it hits the doorknob, it leaves it.
Good, so negative charge builds on him. then jumps to the door. And why do we think this happens? Levi, why do we think that's what happens? All right. Why does it happen? Because like charges repel. The electrons want to get away from the other electrons. So they repel so much they actually jump into the door. We'll pick back up here next time. We'll do station.